All right, so this is your Unit 8 exam review. All right, so number one, you want to find x. All right, so to find any side of a right triangle, you're going to use Pythagorean Theorem. So you're going to use a squared plus b squared equals c squared. All right, so this is a, this is b. Your hypotenuse, which is across from your right angle, is always c. Okay, so a squared plus b squared, 12 squared plus 16 squared equals x squared. 12 squared is 144, 16 squared is 256, equals x squared. This is 400 equals x squared. Take the square root, 20 equals x. Alright, so your third side there is x. Alright, number two, we're going to use Pythagorean Theorem again, but instead this time, this is a, b, and c. We're going to rewrite it a little bit. We're going to say a squared equals c squared minus b squared. Alright? So, x squared equals 14 squared minus 13 squared. So x squared equals 196 minus 169. X squared equals 27. Take the square root. X equals 3 square root of 3. Because it says leave it in simplest radical form. How I did that, I took the square root of 27 and factored it. Well, 27 will factor into 9 and 3. 9 factors into 3 and 3. Since I factored 27 into 9, I can't use them anymore. So, have a pair of 3's. I can pull that out from underneath the radical. Now, I use those because I pulled it out. So all I have left is a single 3. So that has to stay underneath the radical. So 3 times the square root of 3. Alright? Now let's look at number 3. Number 3, we're also going to be using Pythagorean Theorem for. I'm going to use this triangle, even though number 3 is turned around. This is 11, this is 61, and we're finding x. Alright, so we're going to do b squared equals c squared minus a squared. So x squared equals 61 squared minus 11 squared. So x squared equals so this is 3721 minus 121. So x squared equals 3600. Square root x equals 60. Alright, so x equals 60. Now, number 4. For number 4, we have to use our knowledge of the 45, 45, 90 right triangle. Alright, and that's the easiest way to solve this one. We know this is 45 degrees. This is x, this is 26. Now if you remember, your 45, 45, 90 right triangle, alright, the sides across from the 45 degree angles are both s. So this is s and this is s. Let me put them on the inside. And then across from your 90 is your s times the square root of 2 side. Okay? So, your hypotenuse is s times the square root of 2. So now what we have to do is we have to find out what s is. Well, we know 26 equals s times the square root of 2. So now we're just going to take that and solve for s. First thing, divide both sides by square root of 2. So s equals 26 over the square root of 2. But now we have to rationalize our denominator because we can't leave the square root of 2 in the denominator. So, square root of 2, square root of 2. We're going to multiply the top and bottom by the radical in the bottom. So that gives us s equals 26 times the square root of 2 over 2. The 2 and the 26 will cancel to 13 and 1. So x equals 13 times the square root of 2. Alright? So what you need to remember is that both of the legs of the triangle are s in your ratio, and your hypotenuse is s times the square root of 2 in your ratio. You just set whatever you have, like we set our 26 equal to s times the square root of 2, solved for s, and that gave us our side length. All right? Now if you look at number 5 is similar to that. Here we have a right triangle turned on its end, 45 degrees. This is x, this is 5 square root of 2. Alright, so again, since these are our sides, we know those are s, and this is our hypotenuse, so we know that it's s times the square root of 2. Alright, so we know that s equals 5 square root of 2. So to find out what s to the square root of 2 is, all we have to do is take our 5 square root of 2, because that's s. So s times the square root of 2, we're just going to multiply it by the square root of 2. Square root of 2 times the square root of 2 is 2 times 5, which equals 10. So x equals 10. Alright. Now number 6 uses a 30, 60, 90 triangle, which has a different ratio. For the 30, 60, 90, the side across from the 30 is s, the side across from the 60 is s times the square root of 3, and the side across from the 90 is 2s. Okay? So, here's our triangle. It's a little elongated. This was our 60-degree angle. This was x. This was 12. So, we know this is our 30-degree angle. And from our ratio, we know that the side across from the 30 is s. The side across from the 60 is s times the square root of 3. And then our hypotenuse is 2s. Alright, so if 2s equals 12, divide 2, s equals 6. So that means s is 6. And since this is s times the square root of 3, it is simply 6 times the square root of 3 because s is 6. Alright? So that's how you do that. All you have to do is remember this ratio. And that's 2s, not 25. Okay? So that's really all you have to remember. For both of these, it's the two ratios. For the 45, 90, remember it's s times the square root of 2. Alright, let's go on to number 7. I'll leave number 6 on the board while I do number 7. Okay. Easiest way to do this, go ahead and draw a picture. It says that a recreation hall needs to build a ramp. Here's our ramp, kind of steep. It says the ramp must be 2 feet high, and the ramp will start 6 feet from the door. Find to the nearest tenth how long will the ramp be. So we know it's 2 feet high, 6 feet from the door, so we're going to use Pythagorean Theorem to solve for x. 2 squared plus 6 squared equals x squared. So 4 plus 36 equals x squared. So that means 40 equals x squared. Alright, so you have x squared equals the square root of 40. And the square root of 40 is, so x, because it says to the nearest tenth, our ramp is going to be 6.3 feet long. Alright? So that's how you do that. Again, you just set up a triangle, use Pythagorean Theorem to figure out the length of the ramp. Alright, number 8. So this is the triangle we're going to use for 8, 9, and 10. Alright, so the sine of B, the cosine of B, and the tangent of A. Now remember, if you remember SOHCAHTOA, sine is opposite over hypotenuse. So b, this is the opposite side, and this is the hypotenuse. So this is going to be 24 over 26. Cosine is adjacent over hypotenuse. So this one's going to be 10 over 26. And now the tangent of A, alright, so now we have to redo our opposite and our adjacent side for A, because now we're doing a tangent of A. This is opposite, this is adjacent. So tangent is opposite over adjacent. So it's going to be 10 over 24. Alright, so all we did was set up what was opposite and adjacent to our angles, and then we just used SOHCAHTOA to figure out what sides we were looking at. Alright. Now, for 11 through 13, we're going to use these three formulas. A squared plus b squared equals c squared. If that's the case, we have a right triangle. If a squared plus b squared is less than c squared, we have an obtuse triangle. And if a squared plus b squared is greater than c squared, we have an acute triangle. All right? So let's go ahead and get these out of the way. So for number 11, we have 9, 40, and 41. So 9 squared plus 40 squared. Leave your sign out for now. 41 squared. 81 plus 1600. And this is 1681. So 1681. Since it equals, that means it's a right triangle. Alright, since it equals, that means it's a right triangle. Okay, number 12. Number 12 is 10, 16, and 20. So 10 squared plus 16 squared, 20 squared, 100 plus 256, 400. So 356 is less than 400. So that means this triangle is obtuse. Right? Because c squared is bigger than a squared plus b squared, so that means it's obtuse. And now if you look at number 13, we have 12, 15, 18. So 12 squared plus 15 squared, 18 squared. 144 plus 225. Don't know what 18 squared is off the top of my head. 324. So this is 9, 6, 3, 324. So since a squared plus b squared is bigger, it is acute. Alright? So remember, we're just using these three versions of the Pythagorean theorem to figure out if they're acute, obtuse, or a right triangle. Alright? Alright, 14. For 14, we're going to use the Pythagorean theorem. Actually, for 14, 15, and 16, we're going to use the Pythagorean theorem. So for number 14, what I would do first is this. We have 33 and 55 as our side lengths. Set up a triangle. Make the 33 and 55 the two sides of the triangle, and let's solve for the hypotenuse. So we're going to have 33 squared plus 55 squared equals c squared. Alright, so 33 plus 55. This is 4,114 equals c squared. Take the square root. C equals 64.1. Does that work? No, because to be a Pythagorean triple, all three numbers have to be whole numbers. This is not a whole number, so this is not this would not be a Pythagorean triple. So now, here's what you do. Since it didn't work this way, take the bigger of the two numbers, in this case the 55, make it the hypotenuse. Okay? So now 55 squared minus 33 squared equals c squared. Okay? 55 squared minus 33 squared. That equals 1936 equals c squared. Take the square root, and c should equal 44. Now, since 44 is a whole number, that is your third number in your Pythagorean triple. Alright? That is your third number in your Pythagorean triple. Alright, now let's do 15. For 15's sake, for speed's sake, to try not to make this video super long, I'm not going to draw a picture for 15 and 16. We have 42 and 58. So let's do 42 squared plus 58 squared. That equals c squared. So 42 squared plus 58 squared is 5,128 equals c squared. Take the square root, and you get c equals 71.6. Well, that doesn't work either. So now let's subtract them. 58 squared minus 42 squared equals a squared. So 58 squared minus 42 squared. That gives us a squared equals 1600. Square root both sides, and you should get 40. A equals 40. 40 is a whole number, therefore your other side is 40. Alright? Remember, when you get a decimal, you can't use that number. So make your biggest number, in this case 58, make it the hypotenuse. So you're going to do 58 squared minus 42 squared equals a squared. Alright? Now let's do number 16, the last one of these type. We have 60 and 65. So 65 squared plus 60 squared equals c squared. So 7825 equals c squared. Take the square root, and we get 88.5. That's not going to work. 65 squared minus 60 squared equals a squared. So 625 equals a squared. Square root a equals 25. So that is our third number in our Pythagorean triple. Alright? So again, start by squaring them and adding them together. If that does not give you a whole number, take the largest number, square it, subtract the smaller number squared, take the square root, and that should give you the number. Alright? But remember, all three of these have to be a whole number. Have to be a whole number. Alright, number 17. We're almost done with the first page. I'm going to make that bigger so you can see it better. This angle up here is 40 degrees, 20, and x. So we need to find x. Alright, so comparison to the 40, this is the opposite side, this is the adjacent side. So we're going to use tangent. So the tangent of 40 degrees equals opposite over adjacent. Since our variable is in the top, we're going to multiply both sides by the bottom. So 20 times the tangent of 40 degrees equals x. Now that's just simply a calculator problem. You just punch it in. 20 times the tangent of 40. Making sure that your calculator is in degree mode because our angle is in degrees. And I believe it's set around to the nearest tenth. So x is 16.8. X is 16.8. That is our missing side length. Alright, we'll try to do 18 here and leave 17 up for right now. So for 18, we've got to find the measure of angle x. This here is angle x. We know this is 13 and this is 12. Alright, now for this we need to round to the nearest degree. So we have adjacent and hypotenuse, so we're going to use cosine of angle x equals adjacent equals adjacent over hypotenuse. Now, when you're looking for the angle measure, remember you have to use the inverse cosine. So hit the second button, then hit cosine, so you have cosine of the -1, open a parenthesis. Take this fraction as is, put it inside, hit enter, and when you round to the nearest degree, you should get 23 degrees. You should get 23 degrees. Again, make sure you're in degree mode, because if not, it will give you the angle in the wrong system of measure. Alright, turn the paper over. Let's go to number 19. Now, if you look at that picture for number 19, put yourself, for angle, let's start with angle 1. Put yourself in the helicopter. Alright? In the helicopter, you would have to look down to the person standing on the cliff there. So, since you would have to look down, angle 1 is an angle of depression. Alright, it is an angle of depression. So this is angle 2, angle 3, angle 4. Alright, now you're the person standing on the cliff. To look at the helicopter, you'd have to look up at it. Since you're looking up, that's an angle of elevation. Now, you're the person on the cliff still. You look down at the sailboat. Since you look down at the sailboat, that is an angle of depression because you're looking down. Now, you're in the sailboat, you're looking up at the person on the cliff. Since you're having to look up, that is an angle of elevation. Because remember, angle of depression, you look down. Angle of elevation, you look up. Alright? So for depression, you look down. Elevation, you look up. Alright? 23. 23 says, find the magnitude. I'm sorry, that was 25. 23 says, sketch the vector 77 degrees north of east. Alright, 77 degrees north of east. So, draw out your little compass. We know this is north, we know this is east. So, here's our 77 degree angle. That is, in our vector, 77 degrees north of east. Remember, I'm going to call this little arrow here the angle arrow, and of course this here is our vector. Your angle arrow, whatever this first word is here, that's where this angle arrow is going to point to. See how it's pointing toward the north? So that's our first word. Since it starts on east, that is our second word. So this is north of east. 77 degrees north of east. So for number 24, we need 33 degrees south of west. Alright, so 33 degrees south of west. So we know that our angle arrow is going to point south, because this is west, this is south. We know our angle arrow is going to point south, and it's going to start at west. That's 33. Right, it's going to start at west and point south, because it's got to point south and start at west. All right, now for 25 and 26, they want the magnitude of the vector. Easiest way to take a magnitude of a vector. We're going to use Pythagorean Theorem. This is your A, this is your B. So, negative 7 squared plus 3 squared equals c squared. 49 plus 9 equals c squared. 58 equals c squared. Take the square root of both sides. C equals the square root of 58. And that can't be broken down. And yes, I will take it in the simplest radical form. I will always take an answer in simplest radical form unless the problem says round your answer to the nearest tenth. Now, if you do this in your calculator, but you should know the square root of 7 is 49. If you don't put parentheses around this, it's going to tell you, and you just do negative 7 squared, what it's going to do is negative 1 times 7 squared and give you negative 49. So when you're doing a negative squared, make sure you put parentheses around it in the calculator, or it's going to give you a negative number. Same thing over here. This is A, this is B. 3 squared plus 2 squared equals c squared. 9 plus 4 equals c squared. 13 equals c squared, take the square root. C equals the square root of 13. Alright, so that's your magnitudes. Just remember, these are A and B. Run it through the Pythagorean Theorem and find the hypotenuse. Alright, I did something like this in class, so I visually showed you how it works. You end up just making a right triangle. This is one of your side lengths, this is the other side length, and the vector is the hypotenuse of your triangle. Alright, 27. For 27 and 28, we want to find the resultant of two vectors. The resultant is fairly simple. All you're going to do, this is x1, this is y1, this is x2, this is y2. All your resultant is x1 plus x2, comma, y1 plus y2. So this is -9 plus 3, -6, 8 plus 2, 10. That is your resultant of those two vectors for 27. Now for 28, you're going to do the same thing. For 28, they've already put the plus sign in there for you. So we want the resultant of -7, 3, plus -9, 8. So, -7 plus -9 is -16. 3 plus 8 is 11. So there you go. -16, 11. Alright? So again, you're just adding the x's, add the y's, boom, you're done. Now 29 says, explain how triangles can be classified by comparing the squares of their sides. Well, all that means is basically how we classified them back in 11, 12, and 13. Remember, we did a squared plus b squared equals c squared. If that was true, you had a right triangle, and you got to figure out how to put this into words because you should be able to do that. If c squared is larger than a squared plus b squared, it's obtuse. And if a squared plus b squared is larger than c squared, it's an acute triangle. Alright? So that's pretty much all how that works. So for 29, you just basically got to put that in words. Now for 30, it says explain two ways of finding the magnitude of a vector. The way we did it, which is a completely mathematically legitimate way, is using Pythagorean Theorem and making it into a right triangle. Well, what you can also do, because the magnitude of a vector is simply the length of a vector, and what do you use to find the length of a line? Well, you use distance formula. So the two ways are, you can use Pythagorean Theorem, or you can use the distance formula. Alright, that's this formula. Alright, you can use the distance formula. Those are your two mathematical ways to find the length or the magnitude of a vector. Pythagorean Theorem, distance formula. Alright, so this has been your Unit 8 review. Feel free to watch this as many times as you need to. Make sure when you come to class tomorrow, you're ready to take the exam. See you tomorrow.